Now in this video we're going to be looking at simplifying algebraic expressions. But before we get on to that, we need to make sure that you fully understand some of the basic principles of algebra, what some people like to refer to as the boring bits. But it's very important that you're clear about them before we begin. In an expression such as 2x plus 5y minus 3x squared plus 5xy cubed, each part is called a term. So this expression has 4 terms. One way of thinking about this is that each term is separated from the others by a plus or a minus sign. Now we'll be using the name term quite a bit, so keep this idea in the front of your mind. Now I'm sure you know that 3 with a little 2 at the top is pronounced as 3 squared and means 3 multiplied by 3, not 2 lots of 3. Similarly, 3 with a small 3 at the top is 3 times 3 times 3 and is referred to as 3 cubed, and 3 with a little 4 is 3 times 3 times 3 times 3, and we say this as 3 to the power of 4. Well, that's pretty straightforward, but where many people make mistakes is with terms such as 4x cubed. 4x cubed means work out the value of x cubed and multiply the answer by 4. It does not mean work out 4 times x and then cube the answer. If I wanted you to work out the 4x first and cube that, I'd have to put brackets around the 4x like this. You'll remember that things written in brackets are normally done first. Any number before a combination of letters is called the coefficient. So 6 is the coefficient of x squared y in the term 6x squared y, for example. And one last thing before we get cracking, like terms, or similar terms as they're sometimes called, are terms with the same combination of powers of the letters. For example, 7x cubed y squared and 3x cubed y squared are like terms because they both have an x cubed and y squared and nothing else. And we could add or subtract these if we wished. Now 3a squared b c cubed and 7a squared b squared c cubed are not like terms. Sure, they both have an a squared and a c cubed, but one has just b and the other b squared. And that means we can't add or subtract these terms. And so to simplifying expressions, and there are several types we can simplify. The simplest of all is just a group of terms consisting of single letters, such as 3p plus 2q minus p plus 7q. To simplify this, we simply collect up the terms with just p, giving 2p, and terms with just q, giving 9q. We cannot mix the p and q terms. The answer is therefore 2p plus 9q, and that's just about the simplest piece of algebra I can think of. Next comes expressions that have terms involving different powers of the letters, and this is where we need to keep the idea of like terms clearly in mind. Now suppose we are asked to simplify this expression. The first term contains a p cubed and q squared, so we look to see if there are any more terms like this one. And sure enough, there is the term 3p cubed q squared. So we can add these together, giving 7p cubed q squared. Now the next term we haven't used is minus 2p squared q cubed. And sure enough, there's another similar term further down, minus 5p squared q cubed. So we can combine these, giving minus 7p squared q cubed. Now we are left with the two terms plus 2pq cubed and plus 4pq cubed, which are like terms too. So we can combine these, giving plus 6pq cubed. And that's all the simplification we can do with this expression, so that's our answer. The next type of simplification of expressions is where there's a term outside a bracket, as here for example. And we can read this as 4r multiplied by 5s minus 6t, or sometimes we say 4r into 5s minus 6t. The The technique here is to multiply every term inside the bracket by the term outside the bracket. So the answer is 20 RS minus 24 RT. If powers of letters are involved, we must take care of those too. In this example, first we multiply 6p squared r cubed by 6p, giving 36 p cubed r cubed. And then we multiply the 6p squared r cubed by 4r cubed, giving 24 p squared r to the power of 6. And that's that. Now the last type we're going to look at here is where you have several brackets to multiply out and then you have to gather together similar terms. And here's our example. Multiplying out the first bracket gives bm squared minus 6bm. And the second bracket gives 2bm squared plus 4bm. Notice, by the way, we normally write the letters in alphabetical order within each term because this makes it much easier to spot like terms. Now collect up the bm squared terms and the bm terms separately, giving 3bm squared minus 2bm. And here's a slightly harder example of the same technique. Now there's one important thing to remember here. A minus sign outside a bracket changes the signs of all the terms within the bracket. So when we multiply by the minus 3s, the first term in the bracket will become negative and the second term positive. So multiplying out the first bracket gives 5rs plus 5r squared s squared. And multiplying out the second bracket gives minus 15rs, putting those letters in alphabetical order, plus 6r squared. Now we can collect up similar terms, giving our final answer of minus 10rs plus 11rs squared. Well, we've covered quite a bit of ground there, and I think you'll see that confidence with these processes will stand you in good stead as you move up through the algebraic ladder, as it were.